that kind of fun stuff. What it's looking like right now is today is kind of like, we're going to start 6-5 today. Remainder theorems and factoring theorems. We're probably only going to get through the long division part, which is fine. Because the other part of it, we're start talking about the remainder and the factoring stuff, it all uses kind of the same process over the next couple of sections. So we'll get through 6-5 by the end of the day tomorrow. Wednesday, Thursday, and the half day will get us into 6-6 and parts of 6-7. That gets us to Monday. Then we have done school on Tuesday. We might be done with the chapter, all of it, easily by next Friday. Is my best guess. Okay.
In this chapter, this might be a stupid question, but does it matter if we've never done long division before?
No, it doesn't, because I'm going to show you how to do it again.
Yeah.
Yes, ma'am.
Just to let you know, on Wednesday, everyone in French will not be in class. We are mandatory in school field trips.
Oh. Okay. All right. Is it like the whole day, or is it just? All right. So let's do this. Yeah.
It's going to take us so long to finish the whole chapter. You're not going to give it all in one text, are you?
I don't know. So let's talk a little bit about remembering how to do long division. Guys. Now, one of the things that we're using here for long division is just a kind of a quick reminder of is how the process works. Because when we do long division with polynomials, we do the exact same process. So as we start this, we have 37,452. We're dividing it by 12. When you start long division, you ask yourself, does 12 go into 3?
No.
But does 12 go into 37?
Yes.
How many times? 3 times. Where do I place that? Above the 7.
It seems like short division.
Now, watch what I did. Bless you. 3 times 12 gave me 36, right?
Yeah.
Subtract it, you get 1. What do I do with the 4? You drop it down.
14.
Now, does 12 go into 14?
Yes.
How many times? 1. Okay, so I put a 1 up here. 1 times 12 is 12. Subtract it, I get a 2. Bring down the 5. Does 12 go into 25?
Yes.
How many times?
31.
How many times?
2.
He said do it 2 times, so he said it twice.
I got it.
I figured it out.
All right. 2 times 12 is?
24.
Subtract it out. We have a 1. Drop down to 12. What do we get? 12. Now I'm going to change this up because I want to. I just randomly picked numbers and I got lucky. So I'm going to change this into a 3 and throw a curveball. I know. I'm not sure you'll get over it. Yes, sir. No, I changed it to a 4.
I have a legit question. Are we allowed to do it like short division style where we take the remainder, so we put it and we make like 17 and then 14
That's
and 25 and stuff?
numerically, that's great because that's how I would do it.
Okay.
Polynomially, just made that word up. You can't. I know. I'm just reminding you of the process of how this works. So what I did here is I changed it to a 4. So once again, 12 goes into 14 one time. And we have a remainder of 2, correct? Now, we would say R2, but we learned eventually that that remainder was a fractional amount of what you're dividing by, correct? So we would say in 2/12, but then you guys are already saying that you're simplifying it and you write it as 1/6. And that's perfect. Are we okay with that?
Just like 0.16%.
No, don't even worry about it. Just it's 31, 21, and a 6. 37,454 divided by 12 is 3,121 and a 6. And you were happy when you were able to solve that because you were one step closer to being done with your homework. What changes now is that we're going to do and work with polynomials.
Oh, yeah.
Now, when you see these problems written out, your book writes them automatically, bless you, horizontally. Please write them into that division symbol right off the bat. For example, if I'm reading this, I'm just going to write 2x plus 3 goes into 2x cubed minus 7x squared minus 17x minus 3.
Are we doing that program?
And I'm going to write it like that.
No, Jeff, I'm just gonna look at it.
Now, in this case here, is my polynomial in a nice descending order with all degrees shown?
Yes.
Both underneath the division symbol and outside, correct?
Yes.
If there wasn't, what would you do? We put zeros in, or put zeros in for placeholders. Placeholders with division are really necessary because it helps keep everything nicely lined up. So the change between division with polynomial versus numerical is that we're going to try and eliminate terms. Here's what we're going to do. I need to multiply 2x by something to turn it into a 2x cubed. X squared. Everybody agree with me? To multiply 2x by x squared, I would get 2x cubed. Where do you think the logical placement of putting the x squared would be?
Under the 7x squared.
Above the x squared.
What?
I'm placing it there. Now, two reasons that I put it there. First of all, notice I'm multiplying by a binomial. It has two parts. Now, when I distribute this, I'm going to multiply this x squared to this. And I get 2x cubed plus 3x squared. Basically, it's the same thing as if you're divided by 12. And I would just multiply by those top numbers and rewrite below. What do you think I have to do here then? Subtract. I'm going to subtract both of these pieces. And I get 2 minus 2 goes away. Negative 7 minus 3 gives me how much?
Negative 4.
Try again.
Oh, sorry.
And then what do I do next? What do you think the next logical step is? Drop down the negative 17x. Now your job is to get rid of the negative 10x squared. What?
Negative 5x.
By negative 5x. Good. So I put the negative 5x. Distribute the negative 5x to the 2x plus 3. Are we okay with that? Yes, ma'am. I wanted to change that x squared into a negative 10x squared. I'm sorry, I want to take the 2x and change it into a negative 10x squared. So what we're doing is we're backwards, we're multiplying it by something to change it into. Right? So now negative 10 minus 10 is 0, or excuse me, negative 10 minus negative 10 is 0. Negative 17 minus negative 15 is how much? Negative 2, very good. And then bring down the negative 3. How do you change 2x into a negative 2x?
Minus 1.
Negative 1, good. Multiply out, you get negative 2x minus 3. And once again, I'm subtracting both of those. So I have negative 2 minus negative 2 and negative 3 minus negative 3, and that gives me 0. So do I have a remainder? No.
Wait.
Yeah.
If you're multiplying by negative 1, isn't that negative 2x minus 3 minus negative, that seems plus, and then it...
Bless you. What's happening here? What's happening here is you have this 2x minus 3, and you have negative 2x minus 3, and you're subtracting both of these, right? So you have 2 minus negative 2.
Yeah, you're right.
Does that make sense?
Yep.
I don't have a remainder. Is that good or bad? Good. If you had a remainder, it would just be a fractional amount.
So you can write like 2
Exactly.
over 2x plus 3.
It's messy, but that's all it is.
So, 2 over...
So where's the hard
I
stuff?
wish people would say that about
What do you want?
Wait, so if there was a remainder?
I'll show you because I have a remainder next. I'm sorry, I spoiled. Spoiler alert. Yes, sir.
Does it matter where you put them? Maybe like, does it matter if you do x squared minus 2x plus 2, that 2x?
When it says divide this by this goes on the outside and this goes on the inside.
Okay.
Okay, that's how that works.
Good question, man. We have to
Yes. Yes, this is an example of one that you need to put a 0 in.
So is it 0x squared?
Good. So on the outside in this case, we have x squared minus 2x plus 2 divided by, or then goes into 2x to the 4th plus 3x cubed plus 0x squared plus 5x minus 1. Now, the reason why I'm putting in this placeholder is so that way everything stays in line. Okay, everything will stay in line in this case now. First question again. I want to turn x squared into 2x to the 4th. What do I multiply it by? By 2x squared. Good. So now, I want to turn the x squared into 2x to the 4th. I multiply it by 2x squared. And I put it over the x squared. The other reason that I put a placeholder in is notice on the outside, the divisor, it's got 3 terms, which means that when I multiply, distribute whatever I'm dividing by, it should have 3 terms. That placeholder allows me to have a spot for it. So distribute your 2x squared to all 3 of these. We get 2x to the 4th minus 4x cubed plus 4x squared. And I'm subtracting each piece. First term drops, 2 minus 2. 3 minus negative 4 gets me 7x cubed. 0 minus 4 would be negative 4. And then bring down the 5x. And then you duplicate the process. Change the x squared into a 7x cubed. What do we multiply? 7x, good. And notice how it's placed right above the 5x, keeping everything nice and lined up. I'm going to subtract the 2 trinomials now.
That's supposed to be cubed.
Oh, sorry. It's okay. So 7 minus 7 goes away again, which is good because that's what we wanted. Negative 4 minus negative 14 is how much? 10, very good. 5 minus 14. Negative 9. And then I can bring down the minus 1.
That's a long problem.
I have to do one more thing. How am I turning an x squared into a 10x squared?
10x squared.
Right here.
Oh, that one. Yep.
So I'm going to multiply it by 10. Distribute that. We get 10x squared minus 20x plus 20. And then we subtract everything out. And we have 11x minus 21. That's a remainder, right?
That's the remainder?
That's my remainder. Now, is that remainder positive or negative?
Positive,
It's positive, and why is it positive?
because the x is
Because the x value is positive, right? Are we okay with that? So I just make a fraction out of it. Plus a fraction of 11x minus 21 over x squared minus 2x plus 2. And I'm done.
What happens is the x is negative?
What happens if it's negative is you wind up with a distributive property. You're going to subtract, because you're subtracting your term. So if it winds up being a negative 11x, you put the negative there, then it's going to be 11x plus 21.
Can you simplify
Okay.
that down more?
Not always.
Like, can you cancel the x's? I don't remember the rules right now. Don't make me think.
No, you can't do that because they're not monomials. You have addition. You cannot simplify over
Oh, it's
addition.
not multiplication.
Correct.
Okay.
Okay. There are some times that you might have a GCF you might be able to get out of there. That's more of the outlier than it is the norm. It doesn't happen as often as not being able to do anything, okay? All right, it'll be pretty obvious if you can do something, okay? And do one on your own?
Yeah.
Yeah.
Well,
Why not?
I guess.
Why do you make it sound like it takes a long time?
You're not gonna give us a lot of these fucking homework, are you?
He's gonna give us 5 minutes and be like, okay, I think you guys just did 3 of these.
That's just x plus 4. It just looked like, I'll try that.
Oh, man. That isn't this.
I know, so you guys
It's like Cam Jansen.
You're just freaked out because you saw a 0. It's okay. Zeros are numbers too.
I don't like zeros.
I don't like you ain't put up with it.
I don't put up with 0.
You don't put up with nothing?
No.
I ain't got nothing. I'm trying.
Alright. So here's where we're at. I put my placeholder in at the 0x cubed. We okay?
Yeah.
So I need to turn an x into an x to the 4th. Multiplied by x to the 3rd, right?
Yeah.
Okay. Most of you guys probably already did that. You put your x cubed here. Multiply it out. You have x cubed plus 4x. Subtract it out. You want up negative 4x to the 3rd minus 16x squared. Fine. Multiply the top by 4x squared. When you subtract out, you have 0x squared now, right?
Yeah.
What do you multiply x by to turn it into a 0x squared? 0x. Oh, forgot to bring down my other x. Sorry. I'm going to multiply that by 0.
Ooh, it's 0x squared. I didn't.
I multiply by 0x. It's fine. By skipping it, you're doing it in your head, which is fine. I'm keeping it all lined up that we can see where it's coming from. Okay. So if I multiply it by 0x, I get 0x squared plus 0x. And I have to subtract that, and I'm left with x and bring down the 4. And then how do you turn an x plus 4, or excuse me, x into an x?
1.
Multiply by 1. And you get 0. Now, the reason that 0 value shows up, it's because of the placeholder. The whole idea of keeping this, by having that there. Now, do I need to rewrite my answer and write it as x cubed minus 4x squared plus 1? No. And it's from some other people, I've heard this all day today. Did I have to do that? No. What you're doing here is you guys saw that you had a 0, so you just bring down the next 2 terms, and you had to do it with a plus 1. That's fine. By putting placeholders in, it's just forcing you to realize where everything's lining up. That's all it's doing. It forces you to slow down a little bit and go through the progressions on it. Okay? Yeah?
There's like so many steps that it would be easy to skip one.
Is that the whole? Oh, that was a fast class.
Yeah, it actually was.
Do those, please.
Because now in 5 minutes.
You can probably get through a couple of them here real quick. All right. I'll put them up there in a sec.
17? Are you serious? I was looking at the rules and stuff.
How many?
It doesn't say like
5, 6.
I was gonna say 6.
what's on crazy? It's bad.
It's up to the power of the
honestly,
What?
I know the question Calvin.
Who's Rudy? It was 17 through 23, so Lisa put a couple of them up here for you so you could get started.